Okay, math lesson number 9, chemical feed calculations. As I've said before, the second most important job of an operator is to be efficient. This sometimes means an operator must adjust chemical dosages to prevent the loss of chemical from dosing too much, or increase dosage when the treatment is ineffective. Use the ABC math formula sheet to complete the following pie wheel. Now the ABC math formula sheet, let me go into it really quickly. ABC is a certifying body. They've written many of the exams that operators take all around the country and even other parts of the world. This is they call it, ABC calls this the formula conversion table. I've been calling it the math formula sheet. You can see I've highlighted several formulas that we use. You can find the ABC math formula sheets online. If you click on the link to my website below this video, it will take you to my website and you'll find a link to the ABC website where you can download for free the water treatment and distribution formula sheet or the wastewater treatment and collection sheet formula sheet. These are free downloads. I get nothing for it. I'm just giving you a resource here where you can go to my website and click on those links to get free downloads. You're also going to see a link or a download, to the PDFs of every assignment in this math video series with all the answer keys. Once I'm done with this, it'll be converted to PDF and available as a download for a very, I think, affordable price. I think we can afford it. All right, so the pie wheels. I've highlighted the feed rate in pounds per day. This is a formula we'll use to simplify the process here. So they've done this. You can look at this line right here as the line of division. So the number up here, the value up here, can be divided by the value down here. You see 3 pieces of this pie. Each one has its own designation, its own purpose, and they're always in this order. You can think of this, instead of pies, you can think of them as parentheses. This is multiplied by this, which is multiplied by that. Okay, so at the top we have chemical feed, and it's always in pounds per day. This first piece of the pie is flow. The unit of measure is always million gallons per day. The middle piece of the pie is the dose, which is measured, the unit of measure is milligrams per liter, which is the same as parts per million. Remember that for your certification exam. This last piece of the pie is 8.34 pounds per gallon. That's always going to be that, 8.34 pounds per gallon. You'll see on my desk here that I've written down 8.34 pounds per gallon. Just like 7.48 gallons per cubic foot, it's important that every operator is familiar with this. You should know this. When you walk in the door or the front gate to your plant in the morning, you should know that there are 7.48 gallons for every cubic foot. You should know that water weighs 8.34 pounds per gallon. These are things that we should know. Now, what I've asked you to do here in this lesson is to take this circle and draw out your pie wheel for feed. Feed is always going to be in pounds per day. Your flow will always be in million gallons per day. Your dose will always be in milligrams per liter, which is the same as parts per million. And this last piece of the pie will always be 8.34 pounds per gallon. Okay, now you'll notice that there's a blank space between all these, and that's because the flow changes depending on the plant, depending on the day, depending on the time of year. The dosage is going to vary depending on the quality of the water that's going through disinfection or going through a certain process, and the feed is going to change because of all that. All right, so let's start with question 1. Calculate the approximate pounds per day of liquid alum when the flow rate is 8.2 million gallons per day and the dosage is 12 milligrams per liter. All right, so instead of drawing a circle, I'm going to show you how I use this formula to make these calculations. You saw I drew the inside, right? So the feed in pounds per day will be up here. The flow in MGD, million gallons per day, in the first slice of the pie. Then we have dose in milligrams per liter, and then the final piece of the pie, 8.34 pounds per gallon. Let's write in the missing variables here. Calculate the approximate pounds per day of liquid alum when the flow rate is 8.2 mgd. 8.2. The dosage is 12 milligrams per liter. And again, this is always 8.34 pounds per gallon. So this is multiplication. You can think of this as 8.2 multiplied by 12 multiplied by 8.34 with their units of measure. Instead, it's slices of a pie. So let's solve this. 8.2 multiplied by 12 by 8.34, and that's going to give us 820.66 pounds per day, which we can round up to 821 pounds per day. The correct answer is A. Question number 2. What is the chlorine feed rate in pounds per day for a treatment plant with an effluent flow of 8.4 mgd when dosing at 4.8 milligrams per liter? What is the chlorine feed rate in pounds? So feed is a key word there. And pounds per day is the unit of measure. So let's draw our pie. And we want feed in pounds per day. We want flow, million gallons per day. We want dose in milligrams per liter. And the last slice of the pie is 8.34 pounds per gallon. And by the way, if you look on your ABC math formula sheet and go to the conversion factors, you will see that 1 gallon US, here it is here, 1 gallon US is equal to 8.34 pounds of water. When you get one of these sheets, print it up and highlight that fact right there. Just like I highlighted 1 cubic foot of water is equal to 7.48 gallons. Okay? Now, let's continue with this question. We have, flow with an effluent flow of 8.4 million gallons per day. I really didn't need effluent. I just need flow of 8.4 mgd. The dose is 4.8 milligrams per liter. What is the chlorine feed rate in pounds per day? So we are looking for this number here. Let's multiply 8.4 by 4.8, multiply that by 8.34, and we're going to get 336.27 pounds per day. The best answer is B. Question number 3. What is the pounds per day of chlorine if the flow rate is 1,333 gallons per minute and the dosage is 12 milligrams per liter? Got a little bit of a challenge here. Pounds per day, ppd. Let's draw this out. We have feed in pounds per day, which is also ppd. We have flow, which is in million gallons per day. Dose in milligrams per liter, and the weight of water is 8.34 pounds per gallon. So let's draw these variables out here. We want, well, look at this. The flow rate is in 1,333 gallons per minute. Well, I need to convert 1,333 gallons per minute to mgd. I think we've done this before, haven't we? You'll see this in previous videos. So let's rewrite this equation. mgd equals 1,333 gallons per minute. Well, I can look at that and I can say that this is a false. It's false. mgd is not equal to 1,333 gallons per minute. How do I get it there though? Well, I need to convert this to, I have gallons. There's gallons here, gallons here. I've got minutes and I need to convert it to day. How am I going to do that? Well, I know that there are 60 minutes in an hour. You see how minute is below the dividing line, but over here it's above the dividing line? Well, if I multiply those across, multiply them against each other, I can cross cancel out minutes here and minutes here. So I'm going to go ahead and make this multiplication. 60 minutes per hour. Now let's cross cancel. I can take that minute out and that minute out. I have gallons. I'm going to keep that. But here I have hours and I need to get hours today. And I can do that by, well, there are 24 hours to a day. You see how hour is above the division line here and below the division line there? That means I can cross cancel, which means I should multiply. 24 hours to a day. That will allow me to cross cancel hour here, and I'm left with day. All right, let's multiply these across. we have 1,333 multiplied by 60, multiply that by 24, and that's going to give us 1,919,520 gallons per day. This is million gallon per day, MGD. Well, I need to change this to MGD. My unit of measure needs to be an MGD. How do I do that? Well, I'm going to take 1,919,520 and I'm going to divide that by 1 million. And that's going to give me 1.91952. All right. So now we have the flow rate of 1.9, let's call it 1.91 mgd. We converted gallons per minute to mgd. We'll put 1.91 there. Our dose is at 12 milligrams per liter. So let's take that 1.91, we're going to multiply it by 12, and then multiply it by 8.34, and that's going to give us 192.1 pounds per day. It looks like the best answer is C. Question number 4. What is the chlorine dosage in milligrams per liter? If 25.7 million gallons per day is treated with 485 pounds per day of chlorine, what is the dosage in milligrams per liter? This will be fun. All right, so I'm going to draw my division line. Pieces of pie. We have feed in pounds per day. We have flow in MGD, million gallons per day. We have dose in milligrams per liter, and we have 8.34 pounds per gallon. The weight of water. All right. If 25.7 mgd is treated with 485 pounds per day of chlorine, it seems like that might be difficult. But what we can do is draw that line again. Feed 485 pounds per day. We have flow 25.7 mgd. We're going to multiply that by 8.34 pounds per day. All right. That's how we write this out. So we are going to multiply 25.7 by 8.34, and that's going to give us 214.338. We'll call it 214.34. We know this is 485. So 485 divided by 214.34, and that's going to give us, let's get this right here, 2.26 milligrams per liter. The best answer is D. All right. Question number 5. How many pounds per minute of chlorine is applied to a flow of 4.6 million gallons per day? Excuse me, pounds per minute. What am I saying? How many parts per million? Let's write that. ppm is equal to milligrams per liter. All right. How many parts per million of chlorine is applied to a flow of 4.6 mgd if the chlorine scales indicate a usage of 525 pounds over 24 hours? So we're looking for the dose. The dose in parts per million. This will be dose. So let's draw our division line here. Pi, feed in pounds per day. Our flow in mgd. Our dose in milligrams per liter, or also ppm. And the weight of water is 8.34 pounds per gallon. Let's write down what we know. We don't know the dose. We know the flow is 4.6 million gallons per day. The chlorine scales indicate the usage of 525 pounds over 24 hours. 525 pounds per day. Okay. So again, we're going to multiply 4.6 by 8.34. And it's going to give us 4.6 times 8.34, 38.36. We know we have 525. So 525 divided by 38.36. Whoops. Let's do that again. 525 divided by 38.36. And that gives us 13.69 parts per million. 13.7. Correct answer is C. Questions left. What is the chlorine demand if 300 pounds per day of chlorine are used and the residual is 0.72 milligrams per liter in a facility treating a flow of 3.97 million gallons per day? We had feed in pounds per day. We have flow in mgd. We have dose in milligrams per liter. And the weight of water is 8.34 pounds per gallon. Let's write down what we know. What is the chlorine demand? What is the chlorine demand? That was a strange way of putting that, but we're using 300 pounds of chlorine per day. The residual is 0.72. That's a chlorine residual. In a facility treating 3.97 mgd. See, now the residual does not go in this formula. However, flow does. 3.97. You see, there's no place to put a residual. This is dose, not residual. So what we're going to do here is, the reason why they asked for the demand is because, and in a previous video, I explained that demand equals dose minus residual. Okay, so I'm going to save that for the next. First, we're going to figure out what the dose is. So I'm going to draw this line here. We know there's 300 pounds per day. Let's multiply 3.97 million gallons per day by the weight of water, 8.34, and that's going to give us 33.1. All right, 300 divided by 33.1, and that gives us 9.06 milligrams per liter. That's our dose. So let's write this formula out. Demand in milligrams per liter equals the dose, which is 9.06 milligrams per liter, minus the residual. Of 0.72 milligrams per liter. .06 subtract 0.72, and that's going to give us 8.34 milligrams per liter. The answer is B. I love that question. That made me think. Chlorine demand, residual, in what looks like a feed problem. You have to do the feed problem before you can calculate the demand. Questions like this used to really bother me, used to freak me out. I've never been good at math. My entire life I've always struggled with it. This makes a lot of sense to me. Of course, it's my career. I've been doing it quite a while. So as an operator, you want to be comfortable with this math, and teaching this program, whether it's in my lecture series and now on video, helps me use that part of that brain that gets this math, these equations, set into my head. Question number 7. What is the chlorine dosage in parts per million if 13.3 cubic feet per second is treated with 365 pounds per day of chlorine? Well, first off, let's go ahead and draw our pie. We know feed is in pounds per day. We know the flow is in million gallons per day. The dose is in milligram per liter, and water weighs 8.34 pounds per gallon. Now, we have 365 pounds per day. It's asking what is the dosage in parts per million. That answer is going to go here. But it gives us flow in 13.3 cubic feet per second. Cubic feet per second is not MGD. So we need MGD. And what we gave us is 13.3 cubic feet per second. Well, I have cubic feet here, but I don't need it here. And I know there are 7.48 gallons in a cubic foot. I have it right here as a reminder. Well, there's gallons, here's cubic feet. I need to get rid of it, and here it is here, below the dividing line. So I'm going to go ahead and multiply by 7.48 gallons per cubic foot. That's going to allow me to cross cancel. I'm getting rid of this cubic feet. I'm left with gallons here, which is something I need. Curiously, I have seconds, which needs to be converted into days. Well, there are 60 seconds in a minute. I'll write that down. 60 seconds to a minute. Second is over the division line. Over here it's below. That means I can cross cancel these out. And I'm left with minutes, but I need to get to day. Let's use orange. Well, I know there are 60 minutes to an hour. So I'll write that down here. 60 minutes to an hour. Minute is below the dividing line. Over here it's above the dividing line. I can cross cancel those out. Minute, minute. I'm left with hours. Still need to get to days. So let's do there's 24 hours in a day. 24 hours to a day. That allows me to cross cancel again. I can get this hour out, get that hour out. I've got day, which is here. Let's multiply this at 13.3 times 7.48 times 60 times 60 times 24, and that's going to give me 8,595,417.6 gallons per day. Gallons per day. I need to change this to MGD though, so how am I going to do that? Well, I am going to take 8,595,417. I'm going to drop that 0.6. I'm going to divide that by 1 million, and that's going to give me 8.5954 17 blah blah blah. That's MGD. I'm going to change that to 8.6. I'm going to round up that 5 to a 6. I'm going to call it 8.6. All right. Now that we've done all that, let's come back over here, and I'm going to redraw that division line here. We know that we have 365 pounds per day. We're going to multiply 8.6 by 8.34. 8.6 times 8.34, and that equals 71.72. So let's take that 365 and divide it by 71.72, and it's going to give us 5.09. 5.09 parts per million is our dose. 5.09 rounds up to a 5.1 parts per million. The correct answer is A. Last question. What is the number in pounds per day of chlorine if the demand is 3.8 parts per million, the dose is 5.4 million parts per million, and the flow rate is 6,515 gallons per minute? We need pounds per day. That is feed. The chlorine demand, we don't need that right now. The dose is 5.4 parts per million. We can use that. And the flow rate is 6,515 gallons per minute. Well, let's start off by drawing out this. Oh, this is feed in pounds per day. This is flow, million gallons per day. This is dose in milligrams per liter, and this is the weight of water, 8.34 pounds per gallon. Let's write in what we know already. We'll do it in this funky color here. We're looking for feed in pounds per day. The demand, we're not ready to use that yet. The dose is 5.4 parts per million, and the flow rate is in gallons per minute. All right. Let's get our MGD. We want MGD is equal to, flow rate is 6,515 gallons per minute. I have gallons, but I have day. I need to convert minutes into day. Well, I know there are 24. Well, we know there are 24 hours to a day. It's not important right now. What I need is minutes to day. So, I know there are 60 minutes in an hour. Minute is over the division line. Over here it's under. So, I can multiply 60 minutes in an hour. I can cross cancel, get rid of the minutes. I need to convert hours to day, so I know there are 24 hours to a day. Hour is above the division line here. It's below the division line here. I'll multiply it, which means I can cross cancel. Now I have gallons, which is here. I have day, which is there. Let's multiply this out here. 6515 times 60 times 24. That gives me 9,381,600 million, 9,381,600 gallons per day. But I need to convert that to MGD. I'm going to do that by taking 9,381,600, dividing that by 1 million. And that equals 9.38. And that is MGD. So we'll put the 9.38 right there. .38 times 5.4 times 8.34, and that's going to give us 422.50. Why did I draw this? I don't need any of this. Multiply that by that by that, and it's going to give me 422.5 pounds per day. See, what's been bothering me is they gave us this demand. Very often in these questions, especially as you go into the higher grades, it's going to give you more information than you need. Useless information. That's not going to help you answer the question, which they wanted feed in pounds per day. With this formula, if you multiply flow by the dose by 8.34 pounds per gallon, it gives you the feed in pounds per day. The correct answer is D, 423 pounds per day. This lesson was quite a challenge. There's multiple steps to it, and it seems complicated. Please watch the video over and over again. Purchase my download. Print off all these assignments. Use this as scratch paper. Follow me through the video. Do it yourself. Get used to this strategy. It works for me. It works for many of my students. I hope it works for you. And before I go, please like my video, subscribe to my channel, leave a comment, and check out my link to the webpage. The downloads are very affordable, and I would certainly appreciate your support. Thank you.